Hi there, welcome back. This is Weblan. With this one, we want to determine the first derivative of this function from first principles. We know our formula says the first derivative where the limit as h approaches 0 is obtained by f of x plus h minus f of x all divided by h. So we already have f of x, which is equal to the function 2x squared minus 3. We need to find this one. So this one will be f of x plus h is equal to, where we have our x squared there, we add h, or we increase x by h, that is x plus h, and it is squared minus 3. And let's expand this one. It will be 2x, we're expanding this bracket, that's x squared plus 2x xh plus h squared, and this is minus 3. And then 2 by this one will get 2x squared, 2, and this 2 is plus 4xh, and then 2 and this one will give us 2h squared minus 3. So now we have two functions. The first function is f of x, and the second function is f of x plus h, which after expanding gives us this long expression. So now we need to substitute these two expressions into our formula. The formula of determining the first derivative from first principles is f of this, that is the gradient function, with our limit as h approaches 0. This will be f of x is this expression, so is 2x squared plus 4xh plus 2h squared minus 3, and we are subtracting f of x, which is this expression. So we are saying minus, don't forget to put this in brackets, and this is all divided by h. And then we should notice that we have 2x squared minus 2x squared there in bracket, so these two do cancel each other. And then we also have negative 3 minus another negative 3. The double negative creates a positive, so we have negative 3 plus 3. They cancel each other again, so we are left with our result here. As h approaches 0, we have 4xh plus 2h squared all over h, and this one will give us, factor out h here. Our objective is to get rid of this single h here, so let's factor out h here. We have h bracket, from here we have 4x, from here we have plus 2h, and this is all over h. So these two will now cancel each other, so it comes to be the limit as h approaches 0 of 4x plus 2h. Now when we get to this point, we can now allow our h here to reach 0. If we had done it here, if we allow our h to be 0, then we are going to be dividing by 0, and that cannot be possible. So this is now going to be equal to 4x plus 2 times 0, which is equal to 4 x. So from where we came from, our function was f of x is equal to 2x squared minus 3. And from first principles, differentiating from first principles, you'll see that our gradient function, that is the first derivative, is equal to 4x. A little catch up, we made use of the formula, and in the formula you just have to have your f of x, which is this one, and your f of x plus h, which is this one, where we have x, we add an h, or we increase it with an h, and then we expanded it to eventually get this long expression. So f of x plus h minus f of x will give us this long expression minus the function of f of x, and then the difference there, we factor out h, and then we divided by h, we are left with 4x plus 2h, and then we allow our h to be equal to 0. This is reduced to be 0, so our final result is 4x. Continue enjoying.